let's discuss about the Linux history, structure, types of operating system, types of shells, command line interface, file system, inodes, commands with the usage. So talking about Linux, how Linux works, that we have to understand now, right? So Linux and Unix are the operating systems that works for works for the computing society. So, when we are talking how the Linux is working, how the Linux is not working, Unix originated in which year, what are the computing environment, what are the societies that actually done, that we have to find out in this session. So, when you talk about Unix, it's an operating system in a simple and structured manner that we have to study. Unix originated in 1969 as a part of Multics. That is what we have. Multics, which is a multiplex information and computing service project at AT&T Bell Laboratories. Multics was an ambitious system designed for multi-user computing, but it faced several limitations such as complexity and performance issues. Due to these challenges, a new and a simpler system was developed in 1971 at Bell Labs. This new system was called Unix, which stands for Uniplex Information and Computing System. The goal of Unix was to provide a powerful yet simple operating system that could support multiple users effectively. Initially, Unix was written in assembly language, which, however, a major breakthrough came in 1972 when Dennis Ritchie developed the C programming language. Unix was later rewritten in C, making it portable, flexible, and easier to modify. This step played a very crucial role in the widespread adoption of Unix. So, Unix introduces several important features such as a multi-user capability, multitasking capability, hierarchical file system, and strong security mechanism. So, talking about Unix, the major features made it highly reliable and suitable for both academic and industrial uses. So today, Unix has influenced many modern operating systems like Linux and Mac operating system, and its concept is still continue to shape the computing world. So, talking about the powerful features of Unix operating system, multi-user capability when multiple users can work on the system simultaneously. Multitasking when multiple programs can run at the same time. Portability when softwares can run on different hardware platforms. Security, Unix operating provides strong security and user access control. Shell programming supports scripting for automation and task management. So these are the features of Unix. So talking about the concept of command line input and its importance in computing. So, command line interface or a CLI is a type of program that entering text-based commands. Instead of clicking icons and buttons, user type commands to perform specific tasks such as opening files, running programs, or managing the system. Back in the 1960s, computer did not have graphical screens like we see today. Users interacted with the machines through basic computer terminals, and command line input was the only way to communicate with the system. This made CLI an essential part of early computing. During the 1970s and 1980s, command line interfaces became widely used in operating systems such as Unix, MS-DOS, Apple DOS. These systems relied heavily on typed commands for performing operation. So most of the users prefer graphical interfaces known as graphical user interface GUI, which are easier and more software developers and a system administrator feel it feel and have a more control and flexibility. Further, talking about command line interface, professionals can configure system, install software, automates the task, and access advanced features that may not be available through graphical interfaces. Although modern computing has shifted towards graphical interfaces, command line input remains a powerful, important tool in the world of technology. So, moving ahead, let's discuss about the history and the evolution of Linux operating system. So, the journey of Linux began in 1991 when Linus Torvalds released the first version of the Linux kernel. This marked the beginning of one of the most influential open source movement in the computing history. In 1992, a major milestone was achieved when Linux was licensed under developers worldwide to freely use, modify, and distribute Linux, contributing significantly to its rapid growth and success. In 1993, Slackware became one of the first widely used adopted Linux distribution, making Linux more accessible to users. In 1996, Linux got its famous mascot Tux the Penguin, inspired by an incident involving Linus Torvalds. In 1998, major technology companies began supporting Linux, recognizing its potential as a reliable and a cost effective platform. In 1999, Red Hat went further public and further boosting the commercial adoption of Linux. In 2003, IBM promoted Linux on a large scale, even featuring it in a major advertisements, which increased its visibility worldwide. In 2005, Linux gained mainstream attention by appearing on the cover of Business Week, highlighting the growing importance in the business world. And talking about 2007, Linux Foundation was developed globally. In 2010, Linux became the foundation for the Android operating system, which soon dominated the smartphone market. Finally, by 2011 and beyond, Linux powered a wide range of technologies, including supercomputers, mobile devices, and even ATMs, proving its versatility and global market. So, talking further about Linux kernel, talking about its first Linux kernel, which was released to the public with the version 0.01 on May 14 in 1991. Now, talking about it, it had no networking feature and was able to run only on 8386 compatible Intel processors and hardware and had a tremendously limited device driver support. The virtual memory subsystem was also quite basic and still it is basic but still incorporated no support for memory mapped files. So, moving ahead, talking about The further version of Linux that we have is the next milestone that we have was the Linux 1.0, which was released on March 14, 1994. With this release, terminated 3 years of fast development of Linux kernel. Possibly the single significant new feature was networking version 1.0, which incorporated support for Unix standard TCP/IP protocol suite, as well as a BSD compatible socket interface for providing network programming. So this version of 1.0, a wide range of extra hardware support was also included in this release. It is multi-user, multitasking operating system having a full set of Unix compatible tools as well. Linux file systems stick onto the traditional Unix format that we are having a typical Unix we have with us. So these are in this way how it is the Linux is also improving and the typical Unix networking system is used to its fullest. So in conclusion, Linux was evolved from a small student project into a powerful and a widely used operating system that continues to shape the future of technology still today. So this is how it is being say and how the Linux is working. Moving ahead, talking about the operating systems, we would like to tell you that operating systems classified as per the functionality, structure, and the usage. So we have basically 8 type of operating system. We have a batch operating system, which that executes batches of jobs without direct user interaction. It was commonly used in la- early systems like IBM mainframes, where tasks were processed in groups, or we can say tasks were processed in batches. Talking about the second operating system, that is a time sharing or a multitasking operating system. This allows multiple users to use the system simultaneously by sharing CPU time. Examples include Unix, Microsoft Windows, and Linux. So, talking about the third operating system, like it manages a group of computers and makes them appear as a single system. Examples like we have the cluster systems that are developed for this purpose. Talking about the fourth real-time operating system that we have, it processes the data in a real time with a minimal delay and is widely used in robotics, medical devices, and embedded applications. Examples like VxWorks, QNX, and RT Linux. Talking about fifth category of network operating system, it provides networking features such as remote access and a file sharing. Examples including Windows Server, Unix, and a novel NetWare. Talking about the sixth category of operating system, these are designed specifically for smartphones and tablets. Popular examples are Android, iOS, and Windows Phone. Seventh category of embedded operating systems. These are the specialized devices like ATMs, microwaves, and smart TVs. For example, free RTOS, embedded Linux. These are the examples of embedded Linux system. Talking about the cloud infrastructure, cloud operating system is being used. For example, Chrome operating system, Microsoft Azure, AWS Lambda. So in conclusion, each type of operating system that we have studied are being used for a specific task and environments, making them suitable for a different applications that we are having. So, as per the application of the modern computing world, we are using the operating system with the different key functions. Talking further, it is also known that it is also there that operating system is also known as a software system, system software. that helps user operate computer. It acts as an interface between the user and the hardware, making it easier to run applications and manage system resources. One of the most popular examples of operating systems is a Linux, which is widely used in server, desktop, and embedded system. When we are talking about the one of the feature that is file management, in which we can say the operating system manages the files and the directories, allowing users to store, retrieve, and organize data efficiently. Second is the process management. It handles the execution of the programs by creating, scheduling, and the terminating process. It also manages tasks like CPU scheduling and the process synchronization. Then third is a memory management. The operating system controls the allocation, deallocation of the memory. It ensures efficient use of main memory and manages memory as well. Another feature is a multi-user capability. It allows multiple users to access the system at the same time without interfering with each other. Finally, the multitasking. Multitasking enables the system to run multiple programs simultaneously, improving performance and user. So, in addition to this, modern operating system also supports storage management, input output operations, security, and the distributed systems. And in conclusion, we can say the operating system is a crucial component that acts as a bridge between the user and the computer, ensuring smooth and efficient functioning of all the of all the operations being done by the users. So further talking about the Linux, which is an essential system software, also allow the user to operate a computer. It takes an interface between the user and the hardware. So various features we have already studied. Now talking more about the operating system. Now let's study about the single user and the multi-user operating system that we have. So, single user operating system provides a facility to only one person at a time. These systems are generally simple and come into two types, single task or multitask. Common examples include Windows and Apple Mac operating system. Talking about multi-user operating system provides the resources, services to multiple users simultaneously. These are more complex systems such as a time sharing or a distributed operating system. High performance examples include Unix and Linux. So understanding these differences help us to understand that in what kind of environment and as per our computing need, which operating system we have to go for, right? So talking about more about Linux, now on the very top we have a root folder. We have a root as a cryptic folder of the Linux that we have here with us. So a single slash, then root is there, and further it is further the number of other folders are are a part of it, like we have the slash bin slash etc slash sbin and so on. So slash bin is actually holding the essential commands that we use, like we having a list, ls as a list, then cp copy command, grep command, cat command, mb command, nano command, make directory, right? Zipped a file, to unzip the file, touch file, all these comes in the bin. Then after that, we having a etc, that is being your system's brain configuration files for everything, for network settings to user passwords live here. So etc is a system's brain configuration files actually. So talking about sbin contains system binaries for administrative tasks, like we're having fdisk, we're having the rboot, we're having in config, then typically root only directory. So talking about slash USR, we have, which is a massive, it stores users application, libraries that we have, and the documentation as well. So these are the read-only program that we are talking about for the libraries and for the user share for the shared data like manual pages and others. So slash var, that is a variable data files that we are having. We have a logs, cache, mail queues, and the temporary files that persist between reboots. So talking further about slash device, that is dev, manages the device files, slash home stores user directories, slash lib contains kernel modules, slash mnt is for holding temporary mount, slash opt is for optional softwares, slash proc exposes kernel information, slash root is the super user's home, right? So this is how we can understand the structure of the Linux master file. So this is what we are having, talking about the how the default directories or a predefined Unix and Linux directories are actually arranged in root directory, which is the entire file system, and how these are being stored in a hierarchy. We're having a slash bin, slash boot, slash device, slash etc, slash home, slash lib, slash media, slash mnt, slash optional, slash sbin, slash services, slash temporary file, slash multi-user or a single user, slash variable file, slash home directory, and other systems. So this is how default directory system is there. Talking further about Linux file system organizes all files on your system in a hierarchical structure that we are talking about. So slash means we are talking on the top world. So these are how the important directories are containing. Slash bin is containing these kind of a thing. Slash etc it's containing this. Slash home contains this. Slash library slash usr. So this is how it is being used. And talking more about the structure, this structure actually makes the searching of the file more easy. Navigation of the complete file system becomes the easy when we are using this structure, and very, very proficient. It is making the Linux operating system a very, very proficient. So this is how the Linux file system tree is organized, and how the file system and the folders are being placed, how what commands are being present and contained in these different file system that we are having. Talking further about Linux architecture, it is there that Linux is having the three layer structure we have, and one part that we have is the shell, which is this is the part of the operating system which allow user to interact with the operating system by entering commands. It acts as a bridge between the user and the kernel actually. So translating user inputs into the action performing by the system. Shells be a command line based, or it is going to be a like command line based means it may be acting, it may be we are using it, maybe a bash ch file or any kind of a shell we have, or it may be a graphical as well. So they support scripting to automate the task and provide control over system operation, right? So that is what the shell we have. So talking about further, we have a kernel, we having a shell. A kernel is a nucleus of a computer. Talking about the further, kernel is going to be a nucleus of the structure, and it makes the communication between the hardware and the software part. This is the hardware part and this is the software part. This is the hardware part and these other are the software parts that we are having, right? So while the kernel is the innermost part of the operating system, a shell is the outermost one, right? Shell is the Unix term, for an interface between a user and operating system service, and shell provide user with an interface and accepts a human readable commands into the system and execute those commands into the system, and which can run automatically. So this is how it is being used and it is being actually working, right? Which can run automatically and give the program's output in a shell script. So kernel is going to be the heart of the operating system, but the main program in the Linux operating system that helps to run application and manages hardware devices such as the system. When the system is booted, it is loaded into the memory and communicated, right? So this is how it is being done, how it comes into the memory, how it is being done, and it is actually how it is working. So the application program, all the application programs, like we have all these are the application programs. These are the application programs that we are having at this particular application, or your utilities that we are having here, known as a system call. So shell is a command interpreter that provides the interactive and a non-interactive interface between the user and the operating system. And with the help of shell, the user interact with the operating system. So this command entered by the user on the command line and interpreted by the shell and then sent to the kernel. So hardware includes all the peripherals. So hardware is including all the peripherals that we are having actually. Like hardware includes the whatever hardware we are using, like printer, keyboard, everything. So uh, will be working on the computer, hardware, mouse. All these are going to be the hardware part, right? So moving further, what are the user account and what is the need of user account? What is the login ID? So talking and the working culture of the Linux is very much important, and it's very it is very necessary part. Like when a computer is being used by many people, it is usually necessary to differentiate between them so that their private files can be kept private. So this is the main reason why the user accounts were developed, and why the each user is given a unique username, and that name is used to log in. So Linux kernel tracks the user as a numbers only. So each user is identified a unique integer actually, and that is a user ID we have, or a UID we call it. Because number is a faster and easier for a computer to process than a textual name. So that is why it is being for the internal part, the processor is just taking the user ID as a number only. So when we log into the Linux system, we are entering into the shell actually. So originally Unix system shell SH was written by the Stable, and it was known as a Bourne shell when we are talking about the Unix system. But other shell like C shell, like advanced C shell, then being been developed by the Bill Joy. So advanced C shell means the TCH, and the simple C shell means CSH we are talking about. So cone shell is also there. Then in the public domain, cone shell that is known as a PD, right? PDKSH is also there, which is developed by the David Cohn in 1982. And the Born Again shell was also, which is a default shell of the Linux we have with us, right? So this is how the shells, different shells are being developed by different creators, and the different types of shells are there having their different features. So talking about SH, which is a Bourne shell, is originally used by the Unix and the Linux that we are having, and can be used on every types of Unix Linux. So talking about the Bourne shell, which is a quite good in shell programming, and it is not as good as the other shell in handling interaction with the user. So when we are talking about Bash, which is a born again shell, Linux operating system default is an extension of Bourne shell. It is fully compatible with the Bourne shell and adds many features on the basis of Bourne shell. So it can provide functions such as command completion, command editing, and the command history. So it is also contains many advantages of C shell, Corn shell, a flexible and a powerful editing interface, and a very friendly user interface. So we have a CSH, That is a we having a C shell. It is more suitable variant of shell than the Bourne shell. Bourne shell, which is a shell of Unix we are talking about, is a syntax is a very similar. Then right, the syntax is very similar that we have. And then you're talking about TCH. It is extended version of C shell provided by the Linux, right? That we have. And TCH includes the command line editing, programmable word completion, spelling correction, historical command replacement, job control, C language like syntax, and it is not only compatible with the bash shell prompts, but it also provides more prompt parameters than bash shell that we are having. So talking about a KSH, that is a corn shell, it combines the advantages of C shell and the bone shell and is fully compatible with the bone shell that we have. Now talking further about PDKSH, that is the extension of KSH provided by the Linux system. So PDKSH actually supports the character control, which can be suspended on the command line, executed in the background, wake up or terminates the program actually. So, talking about these shells that we are having, that we have studied, now again, the purpose why we are discussing is to understand that on which particular shells, what we have to use as per our requirement. So, talking further, we having a Linux and a Unix comparison. So, a quick thing like we have the Linux is written in 1991, Unix was written in 1969. This is open source, freely available, it's proprietary, it's kernel based system, it's complete operating system. Here we're having individual developers, servers, used in servers, workstation, mainframes. It's free and open, and the Unix is paid or customized cost, security with the fewer threads, and here highly secure enterprise systems we have. And talking about the interface, we have the GUI, we have the CLI. Here Unix is only CLI. Portability, portable across platforms, limited portability. We're having Ubuntu, we're having a Red Hat, right? So here we're having a different kind of a thing. So these are the how we can say we can understand the things and how it is happening. So moving further about the general purpose commands. So we're having a ls and we're having a cd, we're having a make directory, we're having a remove directory, copy command, remove command, right? Move a file, more command, touch command, cat command, impress command. So the detailed execution of these command is also available in the another or another video that is uploaded on this particular channel. So these are here I have just shown it to tell you that these are the most important utility commands of Unix and Linux, right? So this is just an explanation that how it is, how we are actually writing a particular command that we are having. We're having a very first of all, we're having a prompt that we are having, that dollar which is going to be written there, and then after that we have to write the command, and then we have to write the option, then we have to write the argument, right? So this is actually the syntax, and this is how what is we can say the explanation of the command we are having, right? So further, how Linux works actually, what are the various ways how it is being working, what is the shell scripting, what is not the shell scripting, that is very important for us to understand, that we have to talk about, right? So talking about how Linux is working and how it's not working, we have to understand how Linux working is only due to this reason that what are the steps we have, right? So understanding how Linux boots and how it works. For that, let's move and see the another video on this channel. So this is how we are talking about, and we are listening.